So I've gone to modules, and of course we are doing experiment number 3, density, miscibility, and solubility. And you click on the information, you will see that these are the equipment that you need. I have it on my desk as well. And then we have the instructions here. The PowerPoint, you guys can read that. And then of course, what is this? This is the written directions. So between that and this, I guess I have 2. I don't know why I have 2 of these. Okay. Yeah, you don't need 2 of these. It's the same experiment. You can certainly watch the video of me talking about this experiment in the past. Remember that when you guys go to Canvas and you click on modules, you want to upload your right here, your PreLab in this section. Okay, this is what it looks like. You're answering these questions. You want to, these are different sections. That way, when I grade them, I'm consistent and I'm not jumping all over the place. And then this would be your data observations as well as your photo. And then this would be the post lab. So this is the experiment itself. I've downloaded the experiment. And what you guys need to remember is that you guys are, this experiment will go pretty fast. Okay. There are 3 chemicals in your lab kit. It's called density, unknown A, unknown B, unknown C, and then you also have iodines. If you take a look at, these are typical substances and their density. Whenever a substance have a density greater than 1, then it's generally going to sink or be in the bottom if you have a aqueous medium, that is if you have water, and it will generally be on top if you have a water in there as well. So in this particular case, if you have ethanol or hexane with water, it's going to be sitting above the water. If you have something called dichloromethane, it's going to be below the water towards the bottom. So these are typical items that we've measured the density in the past. You guys are going to be using much more safe items. You guys are going to be doing cooking oil and I believe syrup. Okay, so right here it tells you that the density greater than 1, it'll sink. If it's less than 1, it'll float. You guys should also know when you put a substance in, if you're making a solution and you can dissolve more substance, like if you put salt in water, for example, and you put like a pinch of salt in like a pot of water, okay, let's say 2 cups of water, you put a pinch of salt, the water of course will be salty, and you can add more salt and it'll still dissolve. We call that an unsaturated solution. In other words, you can dissolve still more salt in that solution until you reach the saturation amount. Okay, when you reach the saturation amount, then 1 more crystal, 2 more crystals, and it won't dissolve any further. Okay, in fact, if you pass the saturation amount, okay, so that you're adding salt and you're putting it by the teaspoon and you start to see the salt collect in the bottom, the solution itself will be saturated because it's not going to dissolve any more of the salt. Okay, but if you wanted to trick the solution so that it can dissolve more of the salt, what you can actually do is heat it up. The heat will cause the salt to dissolve and then cool it back down to that room temperature. Now, what happens is that the crystals are confused. They should crash out of solution and form a precipitate, but because it was suspended in the water, okay, it's going to stay dissolved. What you can do is if you add a few crystals of salt right on that water that is now supersaturated. Supersaturated means that the solution is holding more than its capacity. Then if you add a few crystals, then everything, all the salt above the saturation level will start precipitating out, okay? But know the difference between unsaturated, saturated, and supersaturated. You can think of a good analogy is a classroom. It's got 24 seats, okay? There's 24 seats. I'm teaching a chemistry class and there's only 10 students. That's unsaturated because the class can still fit 14 students, right? 24 10s in a class, 14 students can still fit in. So it's unsaturated. But suppose that it's time when I'm calling attendance and I have 24 enrolled and all 24 seats are occupied, then that would be saturated. Now, if it's like the first day of class and students are trying to crash a class and I have more than 24, something like 32 in that one classroom, then it's going to be supersaturated. So that's what supersaturated and saturated and unsaturated means. Now, since we're talking about solutions, if you take a solid and you put it in water, like salt, then we say it's soluble. If you take sand and you put it in water, then we say it's insoluble. Insoluble meaning it doesn't dissolve. Soluble meaning it dissolves. Now, let's say that we don't have a solid, we have a liquid, like alcohol. We have alcohol, we take a little bit of alcohol and we mix it with water. Well, alcohol will mix with water. So when a liquid is going into a liquid, we call it miscible, okay? If, however, instead of alcohol, we have, say, oil, okay? Olive oil or some sort of oil, and we put it in water, you guys know that it stays apart. That's because you guys will learn that oil is non-polar, water's polar, so they stay apart. Well, when two liquid do not mix, then we say it's immiscible. So make sure you use those terminology in the pre-lab and post-lab questions, okay? When you have a liquid and liquid, don't use terminology like soluble, insoluble. You use terminology miscible and immiscible. When you have a solid in a liquid, then you have soluble and insoluble. So that's the experiment that we have for today. So if you take a look at the write-up here, remember you're taking 4 photos. It tells you what they are right here. The chemicals you guys are going to be using, cooking oil, syrup, and probably an ethanol or hexane. These hexane is a flammable and it's irritant. You don't want to drink it. Ethanol is also toxic in huge quantity, okay? But don't try and taste any of the liquid that you have. Your unknowns are going to be those. You guys will need test tubes, 10 mil grad cylinder, scale, okay? And then you also need to clean your graduated cylinder between runs, and it has to be dry, because if it's not dry, then it's going to affect the volume for your next liquid and also affect the mass. This is the worksheet that you guys are going to be filling. You're going to weigh the graduated cylinder, and you have 3 liquids. So weigh the graduated cylinder each time because it might be a little bit moist, so the mass might be slightly off, but it should be consistent with each other. Remember, we're using a 10 mil grad cylinder. So if we're using a 10 mil grad cylinder, you guys remember from experiment 2, which you guys are currently doing, that the precision of these graduated cylinder, the delta is 0.1. So you're reading it to the 100th of a milliliter, 0.01, because we're using a 10 mil grad cylinder, okay? So please keep that in mind, that when you read the volume, you're going to read it based on the precision of the graduated cylinder. And that means that you're actually going to fill it up. And if you need to take the bottom off, fine, do that. And you need to be at eye level, and then you're going to read it based on the meniscus of that liquid, okay? So you're going to do this 3 times because we have 3 liquid unknowns. You're going to do the mass as well, and I will show you how to do the mass so that you don't have to take extra steps. And then, of course, if you've got the volume and you've got the mass, then you can certainly calculate the density. And because these are different liquids, then they should have different densities. And then once you have them in the 3 separate containers, you only just need 2 test tubes, because the third one could be your 10 mil grad cylinder. That could be the third container. That way you could minimize in the glassware that you use. But anyway, once you have those, then you're going to mix it in such a way that the most dense is going to be in the bottom and the least dense is going to be on top. So you pour your most dense first, followed by your second, and then your least dense is going to be on top. This is your pre-lab question. Okay, it gives you, I don't know what that box is there for. That's not important, but let's see if I can erase that. These are the mass of the graduated cylinder. The graduated cylinder with the liquid, so you can basically by difference calculate the mass of the liquid. And then this is the volume right here of your liquid. You should be able to read that based on the precision that's shown, and then calculate the density. So this is right here is just your pre-lab, similar to the calculation you would do for the lab. And then right here, use your common sense in terms of what will happen when you take sand and you put it in a beaker of water, or rubbing alcohol and or grain alcohol and put it in what happens when you mix it. So if you're not sure about whether these chemicals are going to be soluble in water or not, you can look them up in the internet. Okay, so that's your pre-lab. It's pretty straightforward. This is your post-lab. The post-lab is going to be based on the data that you've collected, liquid A and liquid B. So make sure you label these things, because this is liquid A, liquid B, and liquid C. Okay, I'll show you that when I show you my desktop shortly here. Okay, and you're going to tell me whether it's miscible or non-miscible, and then you're going to tell me whether the iodine, because it's a solid, is going to be soluble or insoluble in liquid A, B, and C. And that's your lab. It's pretty straightforward. Okay. So let me introduce you to the equipment you need. You need some test tubes. I think you guys have smaller test tube from KLM, but the chemistry, the lab tech just gave me these. These will work fine. You just need a container. You use your 10 mil grad cylinder. You have a scale. My scale is different from your scale. And then make sure that you look for density unknown A. That's the first liquid. Density unknown B. That's your second liquid. And density unknown C. That's your third liquid. Okay. And then you guys can certainly use steering rod and rubber policeman and a Burrell pipette if you need it. But and then make sure that you clean your graduated cylinder between runs. So I'm going to put on my safety goggles. In this experiment, you guys are going to take these, put it onto the side, take your scale and turn on your scale. Make sure it's reading grams. Okay, make sure it's reading grams, and that you tare it. You tare it, basically it reads 0. And sometimes it needs to stabilize, but it should read 0 eventually. Now, if there's wind drift in the room, it'll fluctuate. Okay, so that's 0. So I'm going to put my graduated cylinder on here. Make sure it's dry and clean. And I'm going to record that mass, 21.46. Okay, then I'm going to take liquid A. That's this guy right here. And I'm just going to pour some of them. Be careful so that the liquid doesn't spill over. or you don't mess up and it spills on the scale. I'm just going to pour this into the graduated cylinder. It doesn't matter how much I pour in because I'm going to read the volume. Now, if the liquid sticks, then you will need your glass steering rod so that you can break the surface tension. And then just kind of make sure the liquid goes down. So I pour some, and I didn't pour it all, but I did pour enough. And even if your steering rod is wet, doesn't matter because that's not in the container. It's not in the container. So now I can read the second volume, and then I'm going to put that in my observation. So in your observation, let me just do this real quick. I'll share my computer screen. Hold on. So in my observation, I'm going to be putting the mass of the graduated cylinder for A. That's this, not for B or C. Then the mass of the graduated cylinder and the liquid. So this is, for this case, it's 24.34, okay? Now I know by difference, I can calculate this. It's just going to be 2 minus 1. Then the volume is going to be based on me actually reading this thing, and I got to get at eye level, and then I got to read the volume at the bottom of the meniscus. And if you can't see it, remove the bottom and then read the volume. Okay, so this particular volume for me is about 2.85. Remember, I'm reading it to the 100th of a milliliter. 2.85. Now, that's what I would record right here. Don't worry about calculating the density. The next thing I will do, let me get back to my camera. The next thing I will do is I will go ahead and put this into one of my test tubes. And hopefully it's a test tube that is small. This one's too fat, but you get the idea. Okay, make sure it's clean as well and that there's no liquid in there. Now, if I didn't get all the liquid, it doesn't really matter because I already had the mass and the volume here, and the density doesn't change just because you have a smaller volume. The mass will change proportionally, okay? So the density is constant. It doesn't matter whether you have a swimming pool of liquid or just a drop of liquid. The density is the same as long as the temperature is the same. Next thing you would need to do is that your graduated cylinder is wet. You got to clean it and it's got to be dry. So go ahead and go to your sink and wash it out. If it's syrup or some sort of oil, then water's not going to clean it out readily. So you're going to have to like use soap with that. And then you got to make sure it's dry. Okay. And the way you dry it is you just take a piece of tissue or dry towel and just push it in, and then use your glass steering rod so it goes all the way to the bottom. Make sure that you have a way to pull that thing out. Otherwise, it's going to get stuck in there and then you won't be able to use your graduated cylinder because it's going to be very difficult to remove that piece of paper towel. Anyway, you got to clean it out and it's got to be dry like that. Then if it's cleaned up, if it's clean and dry, then you want to turn on your scale. This will be for liquid B. Make sure you tare it so it's 0. Put your graduated cylinder there. Read the mass. And right now it's different from my first one. Probably has a little bit of moisture there. Okay. Doesn't really matter because what's going to happen? Well, yeah, it does matter because your volume is going to be messed up. Make sure there are no liquid in the bottom. And if you can see mine, there's still a liquid. You can't have that liquid. It's going to mess up your volume. It's going to mess up your volume. So I didn't do a very good job, and that's because I'm trying to rush this. So I apologize. But again, make sure you get paper towel so you can reach all the way to the bottom. It needs to be completely dry. And I knew it wasn't dry because the mass for the second trial was different from the mass from the first trial, which means that there was a residual liquid. Anyway, you get the idea. You can't make that mistake. But let's say that everything's clean. You do the procedure again. You take liquid B this time. You read the mass. And then what I'm going to do is I'm going to pour a different amount in my second tube, okay? If I pour about 3 milliliters on my first, I'm going to try and pour 2 milliliters on my second. Why is that important? Because when you mix all three, you could identify which is liquid A, liquid B, and liquid C by the volume. Okay, if they're all the same volume and they're all transparent, it's going to be very difficult to distinguish one from the other. So, and they're all transparent. So I'm just going to use less than liquid A. And you should also take notes. This one sort of didn't have a, it poured more cleanly than the first. I didn't have to break the surface tension. Okay, so write down that observation. And then I'm going to record the mass right here. Oops, here it is. And you guys can't see it. I don't know why you can't see that, okay? But it is recording something like 24.74. That's what it's fluctuating. I don't think the camera can pick up that, can't pick up that mass for some reason because it can't contrast it. Anyway, I write the second mass with the liquid. Then I'm going to read the volume. And in this particular case, I have about 2.13 milliliters. Okay, I can read that. I think you guys can see that as well. Got to be at eye level, and it's got to be perfectly horizontal. Okay, it's got to be perfectly horizontal. So I have this, and now I'm going to pour it in my second test tube. And I'm just going to pour it in. Make sure your second test tube is clean again. And then I'm going to go ahead and do that. Okay, I need to clean my graduated cylinder. I think you guys have test tube brush. I don't have a test tube brush with me. I don't have a test tube brush with me. So let me go ahead and get a tissue paper. Try and clean this out. I should have just gotten 3 graduated cylinders from the lab. As you can see, I'm not in the lab. I'm at home. So I'm going to go ahead and clean this test tube. Again, it's got to be clean. It's got to be dry. And the reason why you need it clean and dry is because if it's not clean or dry, especially, then it's going to affect your volume. It's going to affect your mass. And then your density will be messed up. Okay. So let's say that this is clean. Doesn't look clean, but let's say it is. I would be graded poorly for my lab technique here. So you do the third one. Okay. You do the third one, and let's focus that. And in this particular case, this is what I will do. I will take the third liquid. Make sure that you close the container for your other two. Okay, make sure you close that so that there's no residual liquid spilling over on your workspace. So I'm just going to do the third one right here. Okay, I'm trying to center this on my desk. So the third one, liquid C, I'm just going to pour it. Tear your scale. Put your graduated cylinder on. Read the mass of your graduated cylinder. That's the graduated cylinder empty. Pour your liquid. And again, I'm going to use even less in this one. Okay, than the other. And what I'm going to do is, read the mass for liquid C. Read the volume for liquid C. Now, okay, you would have all three mass of the graduate cylinder, and if you do this, if they were clean and dry, they should all be similar to each other. The mass of the liquid, A, B, and C, depending on the density and how much you have, the mass should be all different. With the graduated cylinder and the liquid, and then you take the difference. 2 minus 1 is the mass of the liquid right here. Okay, 2 minus 1 for B, 2 minus 1 for C. The volume is what you guys read directly. Remember, it's going to be to the 100th of a mil, and now you can calculate the density. Calculate the density at this point, because what you would need to do now is find your most dense liquid, okay, and then use that as your starting point. The next thing you're going to do is pour your next dense liquid over it, and let me show you how that's done. The liquid that I have. So I'm going to take this liquid. Let me just double check. I know these liquid, sorry, I can't change my camera, have different volumes. This is liquid A, this is liquid B, and this is liquid C. Liquid C, I didn't put in the A test tube because I'm just going to use it directly from the graduated cylinder. The liquid A had the most volume, liquid B had the second, and liquid C had the least. So I'm just going to take this, okay, I hope you can see that, and I'm going to pour it so that it rolls down the side. I don't just want to pour it in and splash it. I want to roll it down the side so that it doesn't mix. Okay, I'm just going to pour it so that it rolls down the side so it doesn't mix. And then what I should have is, if I did this right, you should be able to see, and I don't know if you can see this. Yeah, you probably cannot, because I can't tip this over. I can't tip this over, but there's two liquid that's separated and they're both transparent, okay? But I can see the layers. I can see the layers if I look closely. So the most dense is on the bottom, the least dense is on top, and then the liquid with the least density now is going to be poured. So I'm going to go ahead and do that. And again, you want to pour it down the side so it doesn't upset the surface of the other two. Now this one, you can certainly see that there are layers there, okay? It's easier, I think, if you look at it through here, okay? And you can just barely see the bottom, the three layers there, but you should have 3 layers if you do this right. The most dense on the bottom, oops. The most dense on the bottom, the least dense on top. I apologize. My camera, my computer camera is not. I gotta put my face up there so that can contrast that. It keeps wanting to focus, but you get the idea. You have the 3 liquids. Then last step that you guys are going to be doing is you're going to take your iodine. You should have 2 bottles of iodine. One says iodine and the other one says iodine 4. Save iodine 4 for experiment 4. Take your other iodine. Okay, it should be in baggies and it should be in a vial. And what you want to do is just open it up and then pour the content into the test tube. At which point the iodine will go in one of the liquids. So what I have here is, yeah. Okay, if you look real closely, the iodine's on the bottom and it's sort of like dissolving in one of them. Okay, so what you need to do next is take a rubber stopper. I need my rubber stopper here. So here's what I will do. I will go to the kitchen and get some saran wrap. So hold on, okay? Let me go to the kitchen. So you have to be like MacGyver and just improvise. So I got some saran wrap. You should have a rubber stopper though, because that's part of your lab kit. And I'm just going to, because I need to shake this, but I can't allow it to spill everywhere. So what I'm doing is I'm just putting it here. I've got my saran wrap and then I'm shaking it. Okay. And as I shake it, you're going to see that the liquids are going to mix and the liquids that are miscible will come together. The liquid that is immiscible will stay apart. Okay. And then the liquid that dissolves the iodine will be purple. The liquid that doesn't dissolve the iodine will be clear. So you just have to let it sit for a while after shaking it up, because there's going to be a whole bunch of bubbles. Okay. So based on that, and then again, the way you determine which is liquid A, liquid B, and liquid C is use the size of the layer as an indication of which is liquid A, B, and C, because you use different volumes. If you use different volumes and they're distinct from each other, then you know that, oh, this layer is bigger. It looks like 3 milliliters. That must be liquid A. This layer is the smallest. That looks like 1 milliliter. Looks like liquid C. But here you can see the separation. You can see the separation. It looks like only, well, you guys need to do that conclusion. I'm not going to make the conclusion for you. Okay. But that's your experiment. I told you, easy peasy. Okay. You're basically just taking your liquid, you're weighing them, you're measuring the volume, and then you're mixing it, and then you're adding iodine. That's pretty much the experiment. What you need to do next is just answer the post-lab and put the data in the data sheet. Let me show you that real quick. Put your data on the data sheet here. Okay. Draw a line to indicate the levels of the liquid. Before you mix, draw a line. Which one is A, which one's B, which one is C? Maybe C was on the bottom, maybe B was on top, and A is in the middle. You have to indicate that. Label the colors. Okay, when you add the iodine, stopper it, shake it up, and redraw the different layers again. It looks like two of them do mix. So two of them are miscible. The third is not. Then you guys answer, hopefully you answer the pre-lab before you do the experiment. And then your post-lab is just figuring out A and B, which did they mix? Did they not mix? Justification. That's your observation. Liquid B and C, did they mix? Did they not mix? Justification, your observation. Liquid C and A, did they mix? Did they not mix? Justification. And then here, this part is, did the iodine go in A? Did the iodine go in B? Did the iodine go in C? Justification. Justification is always the evidence that you observe. That's why you, when you're actually doing these experiments, you want to write down your careful observations. That way you can write it here. And then this is just a question that tells you that you've got three solids. These solids could either sink or float. Maybe one is made out of wood, maybe another one's made out of more heavy wood. And it's depending on the density. And a bucket of water, if it's got a density close to water, it's going to hover right in the middle. If it's got a density less than water, it's going to float on top. If it's got a density much greater than water, it's going to sink. But a density that's close to water, even if water is 1.0 and the item's like 1.02 or 0.98, it's still going to hover in the middle. Okay. And then don't forget your photos. Told you this experiment is not difficult. The next experiment is going to be a little bit more involved, but this experiment's one of the easier ones. Okay.